Hello, in this video we're going to look at the ideal gas law and the other gas laws again, but this time we're going to try to relate them. The syllabus doesn't just say that you should be able to use the ideal gas law to solve problems, or that you should recall what the other laws are, but that you can relate them and you see how the ideal gas law brings the others together. So let's try to do that in this video. We've got the ideal gas law, PV equals nRT, that's on the data sheet. And we've got the other laws. Each one expresses a relationship between two variables. Pressure is proportional to temperature, Guy-Lussac's law. Volume is proportional to temperature. Pressure is proportional to 1 on volume. Volume is proportional to number of moles. So each one expresses a relationship between two variables. How does that relate to the ideal gas law? Well, firstly, if we realize that proportionality means one variable is equal to the other variable times a constant. So when we say pressure is proportional to temperature, we mean the pressure is always equal to some constant times the temperature. And in that equation there, if you doubled pressure, what would happen to temperature? It would double. If you graphed that, it would pass through 0, 0, because when pressure is 0, any constant times what will give 0? Temperature must be 0. It's the same with all these laws. Volume is proportional to temperature is the same as volume is some constant times temperature. Pressure is some constant times 1 on volume. And volume equals some constant times number of moles. Sorry, I've covered that. So each of these could be expressed as an equation with a constant in it. So how does that help us get to the ideal gas equation? Let's start with the first one. Pressure is some constant times temperature. We can rearrange the ideal gas equation to give us pressure equals something. Pressure equals nRT on V. What if we hold the amount of gas constant, so N stays constant, and we hold the volume constant? So we take a fixed volume container with a certain amount of gas in it, and we don't change the amount of gas, we don't change the volume. That means N, the number of moles in that situation, stays constant. It's a constant. Volume is constant, and we know R is a constant. So nR on V would all be constant. So P equals nRT on V becomes exactly the same as pressure is some constant times temperature. So what are we getting at here? If you take the ideal gas law and you have a special situation where you have a constant amount of gas in a constant volume, you end up getting Guy-Lussac's law, pressure is proportional to temperature. Guy-Lussac's law is just the application of the ideal gas law to one particular situation. You can do exactly the same thing with all the others. Charles's law expresses the relationship between volume and temperature. Well, start with the ideal gas law, rearrange it to get an expression for volume. It's going to be nRT on P. What would we keep constant? If you keep the amount of gas, N, constant, and the pressure constant, what would happen to temperature? Well, the volume is equal to nRP. They would all be constant, some constant, times temperature. And so you get Charles's law. Now, Charles didn't realize that. He wasn't taking the ideal gas law and simplifying it. He was just studying the relationship between volume and temperature. So he kept the amount of gas constant, he kept the pressure constant, and he watched what happens as he heated or cooled it. What happened to volume? And he found volume is proportional to temperature. But he was actually studying one particular situation, one particular application of the ideal gas law. And exactly the same thing happens with Boyle's law. We could express pressure as a relationship to volume, but notice now volume ends up on the bottom. So pressure is equal to nRT on V. If you keep N constant, and R is always constant, you keep temperature constant, T, then you end up with pressure is equal to some constant divided by volume, or some constant times 1 on volume. That's why Boyle's law ended up being an inverse relationship, not directly proportional. And Avogadro's law, exactly the same. Volume would turn out to be nRT on P, so it's some constant times N. And so you can see each of these gas laws is just applying the ideal gas law to a particular situation where two of the properties are kept constant, and we study the relationship between the other two. And that's why you don't need to learn all these different laws. That's not actually helpful. The ideal gas law integrates them all, and we just need to know how to use it.